Hey guys, welcome back. So I posted this video a few days ago, which is a project I've been working on off and on for the past few weeks, and it's inspired by metro displays on city billboards and advertisement. So today I'm gonna go over a few things about this project. This video is mainly about creating the workflows and all the components that will go into it, from concept to animation to final output. And also I did a lot of exploring to find proper solutions for mask and image compositing without having too much of a messy setup. And also I used, of course, Photoshop and Houdini and Nuke as well for some of the more complex elements, but also you can do a lot within ComfyUI to make your life easier. So without further ado, let's get started. Alright, this is a good workflow to start with. This is the one I'm using to create the animation for the display, and I'm not too concerned about the other elements in the scene, like this guy here like moving around and the stuff in the background, the train, because we're gonna make the train animation and the environment in a different setup. Actually you can use two main things from the shot. One would be the display art, and one would be the light interaction that you can use in your compositing software. Okay, so here we go. So forget about like all these extra sections, and we're going to talk about just the most basic aspect of this workflow, which is a video from an image. And this is the one I created, and we're going to go over this one too. So I built the concept based on my CG elements, and let me show you the actual render elements that I made. So this is the mask. It's a beauty pass. And depth map. So basically, we're going to talk about how we can add animation to this one image. Before that, I'm going to bypass all this because we're not going to use it for now. And we're going to just talk about the most basic one. So this is one frame only, so we have to use a VAE encode and then use a repeat latent badge, and this defines how many frames you want to have in your animation. 16 is good for now, just keep it manageable. And I use a sparse control net to add basic movement to my image. Sparse control RGB is perfect for motion prediction and image interpolation, and you can read more about it on their GitHub page. The next step would be adding additional control and structure to the animation by using depth map and line art control nets. Depth and masks, these passes are coming from Houdini, and I also process some in ComfyUI too. Just like another, other control net models, you have to download these sparse control models and place them in your control net folder. But anyway, so just to test it out, we can just bypass everything and just only use this. And also like this end percent that defines how close you want it to be to your initial image. And the higher the number, the less movement or freedom the model is going to have to generate animation based on your image, if that makes sense. I'm also gonna bypass the IP adapter for now. We're not gonna use it, and let's just test it out, see what we get out of it. So we're going to talk about the LCM animate diff, which is super fast, and that's what I'm using right now. And I'm using evolve sampling. You can look up online and download the workflow, but this is just super straightforward. Using an evolve sampling, animate diff, and you control a model, and you have to have an LCM model here, which is SD 1.5. and the strength is at 1. I'm using a standard static context option, 16 for context length and 4 for context overlap, and I turn this on, use on equal length. We need to use the apply animate diff model. The scale is very important. This defines how much motion you're gonna have in your animation, and I'm using a motion LoRa as well. There are like tons of other models you can use, LoRa's you can use, but I'm using this one. You don't have to, you can just bypass it too. And also for the motion model, I'm using an animate LCM SD1.5. And these are the other models like version 3, version 2. Also, you need to use a sample setting, and you open a sample settings from here. Basically, that's how it works. You just you can just drag it from here and sample settings, and you select empty. And that's about it. And this is pretty much your LCM setup, and this can add animation to anything. You know what I mean? It could be only a text prompt, and it would generate animation for you. But let's go back and see what we got out of this. Okay, so as you see, this is a mess. Everything's just all over the place because it's just generating motion based on my text prompt and the provided image. That's why we need additional control nets to give it more direction. We're not gonna go heavy on control nets, just enough constraint to get it closer to our initial image. Okay, so I'm gonna turn on my depth map control net, and let's give it a shot. Okay, as you see, this is much more interesting. I'm even getting a Nike logo here, which I'm assuming is coming from my text prompt, or somehow is still reading the IP adapter, even though it's bypassed. But anyway, let's see how we can make it more interesting by compositing an image on top of our display. Okay, so I want to talk about this image compositing for a second, but before that, only using this image and applying different IP adapters and controlling the context of your animation using text prompt, you can actually create a lot of cool stuff like these ones. So these are just only different IP adapters, images basically. Like for this one, for example, I wrote spinning boxes or sliding boxes, and you're still using your image to create the animation, just as taking that text prompt into consideration. And also, here's a little trick. It kind of took me a while to figure it out, but this is to place an image exactly where you want it using a mask. This node paste by mask can resize an input image according to the provided mask and place it on top of your base image, which is very handy. And before feeding it, basically I'm cropping this image to a proper size. And now I'm gonna use this new composite and create a new video. Okay, so and the mask is coming from one frame of this image because the camera is locked off, it's not moving, so any frame would work. And I'm using a red channel, using a mask from RGB, and using a red channel, and you have to convert it to an image, and the image goes to the mask input. And that would be the channel that this node is using to place this image on top of this base image and place it properly. And then you can use the keep ratio of it, which is kind of resizing the image, or you have different options based on your need. Still gonna bypass the IP adapter just to test it out and keep the text prompt. So let's check it out. Okay, as you see, it's cropped. Use the mask and placed it perfectly where it's supposed to be, and it's going through the rest of the pipeline. Alright, so this is what we got. It's not very close to, what I had in mind. And one of the reasons is that, first of all, you need to maybe just add a little bit of this to the n%, just to kind of keep it together as far as the how close it is to the initial image. And also this additional control net might help to give it more structure. I'm just using a little bit of it just to give it direction. I'm not using too much of it. So why is it just switch back to so let's test it out. Alright, this might be a good time to bring the IP adapter back to just give the video more consistency, and make sure that we can apply the initial image properly. There we go. Now we have it back. Now what I'm gonna do, just put it back at 0.6. This one might be a little too much. And what I'm gonna do, I'm gonna activate this IP adapter. Alright, so let me just explain the function of the IP adapter here. I'm using two IP adapter tiled, and they're connected, and they're so this one and this one, they're affecting this, different aspects of different part of the image. This is only for display, and this is for the rest of the image. And what I'm doing is that basically for the environment, using this attention mask input, and the mask is coming from the red channel, but I'm inverting it, so this would be a red channel and the invert would be this, so it's only applied to the environment, and I'm connecting it to the attention mask of the second IP adapter. And the first one is only for display, and I could have just only used the red channel that's coming from here, which I'm using a mask from RGB and using a red channel. I could have only used that one to apply it to the screen, but I'm also multiplying an animated mask on top, which is just using an image composite mask, and I'm compositing this with the empty image, 32 batch size, that's just the number of frames we have. And after multiplying this mask, and after multiplying this image composite by this mask, you're gonna end up with something like this. And I'm using another mask from RGB and using a white channel from this, so this would be our generated mask. So instead of just using a red channel, I'm using this to just keep it more interesting, and I'm connecting this to the attention mask of the display IP adapter. Okay, there you go. This is way more interesting. I also increased the number of frames to 32. By the way, just a quick tip about Video Combine. When you create it, the default number for CRF is 19, which is supposed to be an optimal number in terms of the right balance between file size and the quality. I usually bring it down to 13 or 14 just to have more quality. You also have options as far as different formats like ProRes or something like that, which is a very heavy file. But this is good enough for now. Okay, so I also have this little workflow to up-res the video. I'm using an upscale image using model, and the model is 4x ultra sharp, which is 4 times bigger, and I'm going to downscale by half and add a little sharpening to the video, and using a film BFI to interpolate the frames just to make it smoother. And that's about it. And if you want to keep the same speed as this video that you had previously generated, you have to multiply this number, which is the multiplier for VFI, by the original frame rate and so in this case it would be 24 just to match the speed of these two, but in this case I don't mind to have it, you know, half the speed, so I'm gonna put 12 or the same number, pretty much ignoring this, but yeah, that's about it. Alright, so let's talk about how we can segment different part of this video. The first one also, I want to mention how we can, you know, export something that would be useful for, you know, light interaction, you know, as far as compositing. So this is what I'm talking about. If I do like an image to mask and use the intensity of it, let's preview this. Mask preview. Also, one more thing I want to do, just move these a little bit here. I can still like use this guy, the mask I created, which is here. Just do a reroute, bring this here. I can do this is the mask. Oh, not the image. Empty image. 960, 540. So this would be our destination, I guess. This would be our source. Another video. Combine, don't want to save it. Let's do 12. And that. And this has to have the same number of frames, 32 is the batch size. Okay, let's create it. Let's process this. Alright, so this is one way to mask a section, but this might not be very accurate since the shape of the display is slightly changed. The outline is slightly changed, but you just wanna, if you just wanna isolate this section and don't wanna deal with, you know, rotoing, this might work, but I'll show you a better way to be more accurate. Let's also look at this intensity mask that might be useful to use for a light interaction in Nuke or, you know, After Effects. Just thinking outside of a box here, but it's up to you. Now let me show you another way to segment sections. Okay, so for this one, we're gonna go with choose grounding DynoSam segment, segment anything, and what you need is a SAM model. You know, you can pick the default, and we need the Dyno model, and you know, I'm gonna go with this one. And you can connect your image here, and for the device mode, like CPU and auto never work for me, so I always go with GPU, and it's faster too. And basically for the prompt, now you can specify what you need to segment. So for this one, I'm going to choose the screen. Mask preview. Yeah, as you see, it does a better job as far as the corners and stuff like that, so it's actually pretty successful. It's actually very impressive. let me do the train, maybe. Okay, very good. For a couple of frames, it's including the platform too, but we can play with the threshold to fix that. We're going to increase it to like 0.45. Okay, great. That's fixed. You can always blur and expand the mask too if you need to, but this is good to go. So I was going to cover the image generation part in this video too, but I'm going to make another video for that, and we're going to talk more about the animation as well, since this video is already long enough. But maybe just to show the process, I'm going to apply the animation to the subway train very quick. So pretty much this is the workflow. I'm using the depth map to add motion to the train, but to be able to have more control over the element, I'm isolating that section using my mask. Then I connect that to my depth control net. But as you see, there is quite a lot of image and mask compositing is involved. And also I have 2 more animate diff layers to improve the animation of the display and enhance the face, which we can go over in the next video. Let me know if you want me to cover the Houdini stuff too. I would be more than happy to do so. Okay, I guess that's it for today. I'll see you in the next one. Peace.